All right, 6th graders, we are on section 2.1 in the 8th grade book, and we're going to start talking about geometry, in geometry terms, more specifically congruent figures and transformations. All right, so if we're looking at our key idea about congruent figures, notice that it says that figures that have the same size and shape are called congruent. Now this is where you have to understand that in a triangle, for example, if you have two congruent figures, you're going to have matching sides and matching angles. So since a triangle has 3 sides and 3 angles, you're going to have a total of 6 corresponding parts that are congruent. But that's only for a triangle. If you, for example, had an octagon, that would have 8 angles and 8 sides, so you would have 16 corresponding parts to label. So if we're looking at this, congruent figures, there's your vocab word, congruent. The corresponding angles are congruent, they're matched. Angle B is congruent to angle E. Now notice that little red mark. That means the arc marks are congruent. Matching sides are also corresponding. Now, if you would name them, or if you would write them as congruent, you would do this. Segment AC is congruent to segment DF. Segment AB is congruent to segment DE. Now, notice those tick marks. The reason why I can't put 1 and then the same one here is because then you're telling me all 4 of them are congruent, and they're not. So every set of different sides, you make a different symbol. So I could just make little tick marks like that to say they're congruent. The same thing is true with angles. Since I've already used 1 arc mark, I can now use 2 arc marks and say that angle F is congruent to angle C. And I could use 3 arc marks to say that angle A is congruent to angle D. In this example, all we're going to do is name our congruent parts. So since the figures are congruent, we know that all corresponding angles are congruent and all corresponding segments are congruent. Now, I'm not sure how familiar you are with actually labeling sides and angles and such, but in case you don't know, we're going to go over that now. Corresponding angles. Whenever you make an angle symbol, you name an angle with either 3 letters. So, for example, you can say angle DAB, or you can just say angle A. So we're just going to use angle A right now. But you would use the angle symbol. That's the angle symbol. Angle A and angle W are congruent. Angle B and angle X are congruent. Angle D and angle Z are congruent. And angle C and angle Y are congruent. Now, if we name the corresponding sides, they're all segments. So we would say segment AB, or you could say segment BA. Now, segment, we have to put a segment symbol on top. And we could actually say is congruent, and that's actually what we put here as well instead of and. So segment AB is congruent to segment WX. Segment AD is congruent to segment WZ. And we continue that on. And the rest of the sides are congruent. Notice we have 8 total corresponding parts. As we just said, identifying congruent parts. 2 figures are congruent when corresponding angles and corresponding sides are congruent. So if we would say, notice all the arc marks. This is how they're written. To say that these 2 triangles are congruent, you would say triangle ABC is congruent to triangle DEF, and it has to go in that order. You cannot say triangle ABC is congruent to triangle FED, because notice that A and D line up. That's why they're color-coded. B and E are green. C and F are congruent, so we have to go in the same order. Now, you could have said this, triangle ACB is congruent to triangle. Now, if we went ACB, you would go DFE. Triangle, whoops, DFE. So that would also be appropriate. And notice here that this symbol, which is an equal sign with a wavy thing on top of it, means is congruent to. So if we look at example 2, which square is congruent to A? This is pretty easy. We know all of the angles are congruent because they're all 90 degrees in a square. But since C also has the same sides, A and C would be congruent. Really easy. In example 3, we know that these trapezoids, ABCD and JKLM, are congruent. What is the side length of JM? Now, something that you have not done yet, but I want you to understand, is that if I say JM with no segment bar on top, this means the length of. If I put JM, that's just the side segment JM. So when you have no segment bar on top, that means we're talking about finding the length. So segment JM would have a length of, well, if they're congruent, it would be 10 feet. Really easy. What is the perimeter of JKLM? Well, since they're congruent, they're the same shape. So all we have to do to find the perimeter of JKLM is add together 6, 8, 8, and 10. So if we did that, the perimeter of JKLM would be 32 feet. This is pretty easy. Your vocabulary would be corresponding angles, corresponding sides, congruent figures, and congruent. In section 2.2, over translations, you probably in the past have done sliding. That's what a translation is. Now, a transformation. Now, a transformation is any time when you change a figure into another figure. The new figure is called the image. The original figure, which I'm going to make you write this down. The original figure is called the pre-image. So the pre-image is before, the image is what happens after the transformation. Now the transformation could be a translation, a reflection, a rotation, a dilation. Now a translation, which is what we're doing today, is a transformation in which a figure slides, but it does not turn. This is important. Every point of the figure moves the same distance and in the same direction. So this red trapezoid to this blue trapezoid would be a translation. In example 1, it says, tell whether the blue figure is a translation of the red figure. Yes, here your red figure slides left and then down. So yes, this is a translation. This one rotates, so this one would not be a translation. Now you need to take good notes on this and take your time at understanding this. This is the algebra behind a translation. To translate a figure, A units horizontally, that would mean left to right, and B units vertically. In a coordinate plane, you're going to add A to the X coordinate, so right here's your algebra. We have the ordered pair XY. A tells you to go left or right, so we do X plus A. B is the Y coordinate, that tells you to go up or down, so that would be Y plus B. Positive values of A and B represent translations up and right. Negative values of A and B represent translations of down and left. And here's your most important thing. In a translation, the original figure and its image are congruent. This is it. Star this. You may also call this a rigid motion. A rigid motion is a transformation in which the preimage and image remain congruent. Here's the other thing we have to be careful of, and I'm pretty sure this is new to you. When you translate something, or when you make a transformation, this is important. When you make a transformation, the preimage is just your A, B, C, D. And as you can see here, the preimage would be triangle ABC. So we would write this as triangle ABC. After you translate it, the image, after the preimage, the image is read as A prime. Use prime symbols when naming an image. So A becomes A prime, B becomes B prime, and C becomes C prime. So triangle ABC would slide to the right and then down to give us the image triangle A prime, B prime, C prime. So in example 2, we're going to translate the red unit 3 units right and 3 units down. So point A is at what vertex? Or at what, well, the vertex or the point of negative 2, 1. Point B is at 2, 5. C is at 1, 2. So what happens to each of these? Well, 3 units right means I would add 3 to the x value, and 3 units down would mean I'd subtract 3 from the y value. So A prime, B prime, and C prime, well, A, if I add 3, would become 1, negative 2. B prime would become 5, 2. And C prime becomes 4, negative 1. So if you graph those, and I'm going to do it in blue, I would move every point right 3, down 3. So right 3, down 3. So A becomes 1, negative 2, A prime. C would go right 3, down 3. That'd be C prime. And B goes right 3, down 3. And that's B prime. And if you check these, let's see. 1, negative 2 is correct. 5, 2 is correct. And 4, negative 1 is correct. So the coordinates would be these values right here. So example 3, I'm not going to go through the motions here, but you can see it over to the right. The vertices of square ABCD are noticed in red, so this is the pre-image. Draw the figure in its image after a translation of 4 units left, 6 units up, and this is what you get. Square A prime, B prime, C prime, D prime. Here are the 4 words that you need to write in your notes for the vocabulary for section 2.2.